welcome learners once again for the MOOC module on handling large scale unit level data with Stata. This is one of the unique platform where we are trying to cater to the need of the researchers, especially the PhD students or the budding researchers in different institutions for their future endeavor in achieving or targeting for a particular large scale unit level research. So, myself Pratap Mohanty have been teaching this particular module on sampling and its design, data handling for over several years in different platforms. So, therefore, I can I will try my best to nurture you these techniques very systematically. Wherever you have difficulties, you may raise these questions in our question forum of NPTEL. There is a column called ask a question. If you raise your question, we will certainly cater to your need as early as possible with the help of our TA. The TA is Shruti Subhan, and Shruti Subham is a PhD scholar in our department under me. So, and she has been preparing the details over time, and these PPTs are largely also held by her. So, therefore, I will specify the particular need usually desired at this level. So, that we are now starting with the week number 2. In the week number 2, we have a separate discussion as compared to the first week. In the first week, we discussed the familiarization of data, understanding data through different data sets available in India. But here we are taking you to the journey of understanding samplings, because without samplings we may not understand the questionnaire of those data set correctly. How those questionnaires actually dealt? What do you mean by sampling? Even if a large data set is presented before you having more than 6 lakhs observation, that does not mean that is important to you. Okay. Entire data set surveyed by the government may not be important, even a small sample out of it is very important. You may also take repeated sample, number of samples, iterate number of times, have an experiment of some cluster of sample out of it and test your requirement or your variable whether it is actually generalizable or not. At what level, if you increase the number of sample units out of the bigger sample, whether still your result hold or not is very important. Okay. So, therefore, sampling technique is very important. I will also add what other details of sampling. So, let me take you to the further details of it. So, therefore, the module the first lecture of week number 2 is defined as review of sampling sample techniques. So, review of sampling or sample techniques is important. Now, the picture itself tells story. Now, I need not specify other details than challenging your understanding on it, because it seems as if there is a genesis and a species on it. The species may be discussed about the genesis in a very different manner. Okay. There are number of narratives defined from this particular picture. You can tell lots of stories, like let me help you here. Here is the population. It seems that is the entire population, or the number of persons within this group, the bigger circle is more than that of the small one. Now, we selected, somehow we selected, filtered it and derived those small number, or I name it as species. Okay, but actually the right term is not species, it is simply called sampling. Now, it may be the case that these 1, 2, 3, 4, 5, 6, these 6 people are selected. It may be the case that this one is selected, this one is selected, this one is selected, this one is selected. We do not know these 6 are selected. There are different possibility of selection. So, the approach of selection actually matters. If I simply select this because this is very closer to my hand or closer to my locality, so therefore, these 6 are important to me. And if I have certain experience in selecting the persons from a group, instead of following a complicated sampling procedure, I may select some specific person and I know that they can represent the entire population. That is also another approach of selecting the sample. The most simplest format of selection is the simple random sampling, but random sampling has lots of limitations. Now, as I said, this may be selected, this may be selected, anyone, if any one single individual has equal chance of selection in the sample, is actually called random sample. But it may be the case that the population itself is not normal, in the sense that they are not homogeneous. If they are heterogeneous enough, okay, randomness may not be actually giving you the right result. Okay. If they are too heterogeneous, but you have selected the 5 or 6 or the sample, but the sample actually discussing about a specific people with some similar features, they are not covering entire one. But if the population is skewed, okay, skewed maybe positively or negatively, but you have applied a random one, the random actually will result in a skewed distribution in the sample database also, or sampled database also. So, therefore, first assumption of selection is the characteristics of population, whether it is normally distributed or randomly distributed or not, or they have equal chances, homogeneous or heterogeneous. Accordingly, different formats or different sampling design is developed. Now, you might be also surprised asking yourself, why sampling, why should I bother for sampling? I have a slide completely dedicated to it to answer why sampling is important. Let me mention you a few here, that it is very cost effective. Now, imagine our population in India is exceeding 130 crores. Now, 130 crores and counting that 130 crores is merely impossible, and it is possible, but if you are including very less number of variables. If our target is to analyze the very specific information on it, then counting is fine, like we do follow census in every 10 years. Now, even Government of India is presently thinking of NPR, National Population Register, of counting each population. But now there are number of questions raised, that how could you able to do it, it is consuming time, space, money or expenditure, so it is very difficult to deal with. So, the most important aspect of sampling or survey through sampling is to minimize cost. Second one, sampling also minimizes error. When you start counting all the population, there are high chances of under reporting if you directly get those specific information, and report maybe under reporting, or maybe the case that many information are hidden at the point of counting, or it may be the case that while since it is 130 crores times minimum 20 or 30 variety of information you asked, now 130 crore times 20 or 30 variables. Now, the information in each block is too huge. So, there are high chances of error in the entry of the data. So, in the non-counting procedure also, while you enter and feed the data in the computer, there are chances of major errors, whereas in the sample, chances of those type of errors are very less. Okay, entering data, because number of variables are limited, but features are different. So, we will discuss in detail. So, whatever I said, I am just going by it in a structured manner with detailed point. So, let me read between the lines of some of the important points. I do not want to skip certain context. So, all the objects, what do you mean by population? I am referring that all the objects that have particular characteristics of interest to the researcher, or aggregate of units of observation, either animate or inanimate, about which certain information is required. I have already discussed, so I need not give further explanation to it. The population of India is defined as all population residing in India. Population can be homogeneous or may be heterogeneous. Accordingly, the sampling design is framed. What do you mean by elements in the in our procedure? A single member of any given population is called element. Within the population, if a single member is referred, we term it as element. As I already said, population may be homogeneous, may be heterogeneous. If it is homogeneous, usually this is not the character of population, so far as populations are concerned. If it is so, then we can derive a sample. If it is heterogeneous, we will also derive the sample. But usually when the population is having similar characteristics or more or less homogeneous, the sample size you need to derive should be very less. Whereas if it is heterogeneous, the sample size generally expected to be higher, then only you can cater to the larger population. Okay. So, different colors are given deliberately in order to describe you how we can represent our sampled data while interpreting to a larger population. So it is interesting to note. It may be the case that our population is heterogeneous, like there are different colors. If you combine those colors or if you cluster them in a different format, if you combine same color differently, like red color in one place, black color in another place, pink color in another place, after combining or making them cluster, we can then randomly select the clusters. That will simplify our sampling procedure also. So, not necessarily homogeneous sample data or heterogeneous sample data should be different, but ideally when your characteristics in the population are homogeneous, you need not go for more sample number, okay, because a small number of sample might generalize the context. But when it is heterogeneous, you have to make it different data, then each data you have to collect certain information on it. There are some standard rules by which you can decide the sample size that will represent the whole population. Our next lecture will be on that, understanding the sample size which can able to generalize the data, entire population, and so that the error will be minimum. Now, looking at sample, what do you mean by sample? I already said that those are only some elements selected from the population, so therefore we call it sample. When all elements are selected, we have already mentioned called census. A subset of individuals within a statistical population to estimate characteristics of the whole population is called sample. What do you mean by sampling units? Already mentioned in our NSS NSS example, NSS schedule, that sampling unit are the units which we actually sample. We collect the exact household or the exact individual. Generally our sample unit is household considered in different database, whereas sampling frame is the entire sampling units which are collected. It is a list of all the sampling units called sampling frame. What do you mean by sampling design? The way by which you have actually collected your sample, the structure by which you have collected the sample units, or the entire sampling frame is made based on a design or a structure is called sample design. Then why sampling? So therefore, as I mentioned, therefore it is interesting because it minimizes cost. So it is the population of interest which is usually too large to attempt to survey of all its members, and complete enumerations are practically impossible when the population is infinite. It reduces the cost of investigation, I have already said, time also, and it gives the results with accuracy and which can be presented mathematically. There are different indicators of validating our sample. So we have a dedicated lecture for it also, understanding the accuracy, precision, accuracy, validity for sample. What do you mean by efficiency in this segment, in this lecture, in this sampling frame, or what do you mean by what are the prerequisites for a sample? It is efficiency, representativeness, measurability, size, coverage, goal orientation, feasibility, economic or cost efficiency. So, efficiency we do mean that the sample should yield the desired information. The target information you must have said from the beginning, or the hypothesis you have said, or the research question you have said in your research must have actually dealt. Representativeness, what do you mean by that? It must be actually covering the parent population. It could derive inferences. The sample actually should be in a position to derive lots of inferences, and those can be comparable to the population features, to the entire population which we discussed, with measurable precision and confidence. So far as measurability is concerned, the design of samples should be such that the valid estimates of its variability can be made. Sample size matters. It should be large enough to minimize sample variability. If the variability is less, it is actually good to represent the population and to allow estimates of the population characteristics with a measurable precision. Coverage, so far as coverage is one of the features of a sample is concerned, adequate coverage is essential if the sample has to represent the entire population, or if it is representative. It must have a defined goal. Sample should be oriented towards the study objectives of research design, as I mentioned. Feasibility, the study should be sample enough to be carried out in practice. I mean, sometimes we frame a research question and we propose a sample, but technically it is not feasible. Okay. So, for example, if I just simply mention that what is the probability of a person to be live if the person is actually moving to moon. Okay. If this type of objective or research questions are there, because we do not have a population in estimating how many are moving to moon and what are the other variability in this regard. So, it is practically impossible to study. So, it is very important then. So, economy and cost effectiveness is very important, as I mentioned, because it saves time as well as cost. So, let us have a sample design, as I mentioned already. So, we start with defining a population, what is our total or the aggregate information in this regard, and we need to define the sampling frame. I have already discussed that. Then we need to follow the right sampling procedure. In order to derive or execute the sampling design, we must have followed a right sampling procedure. So, sampling procedure follows two approaches: probabilistic structure or non-probabilistic structure. Probability structure we do mean where the probability of selection or the chances of being represented in the sampling frame is equal. When each person of the population we are targeting, or the entire or the aggregate information out of which a particular information is actually represented in the entire sample frame should have equal chances. So, therefore, the type of procedure followed are usually of simple random sampling, stratified sampling and cluster sampling. These three are usually followed. Whereas, in case of non-probability sampling, we generally follow convenient sampling, judgmental sampling and quota sampling. So, accordingly, once you follow the procedure, the type of sample procedure we consider, then we can understand what exact size is important. Random sampling generally cover more sampling units, whereas if you follow a right procedure, multi-stage sampling procedure, it minimizes the units. Okay. So, okay, then let us go for further details of sampling techniques or the procedure. So, it based on the randomness, as I already mentioned. Now, starting with simple random sampling, systematic sampling, stratified sampling, cluster sampling, area sampling, multi-stage sampling. These are part of probabilistic sampling or random sampling, whereas non-probability sampling covers judgment sampling, convenient, quota, panel, snowball sampling. So, I will be explaining each of these steadily. Now, let us start with the random sampling. Random sampling already mentioned, the chances of selection is equal for each of the units within the population to be selected in the sample. So, each have equal chances, and now this is recommended actually when it is homogeneous, the each person has equal probability. The technique is actually based on randomization principle, wherein we generally follow the random table or the random data set available to start from a point of selection. I will discuss you in the next slide. This guarantees that each and every individual of the population has equal selection opportunity. This helps also in reducing possibility of bias, because we are not differentiating persons from persons within the population space. So, looking at the simple random sampling, once again this is applicable when population is very small, but if population is very large, it is generally heterogeneous, not homogeneous. Okay. So, first of all it should be small and it should be homogeneous, and it should be readily available. When you do not know what is our population, as I just given you an example where our population is not defined, so sampling is very difficult. So, here each unit in the population has equal chance or probability to be selected in the sample. The procedure involved in a random sampling is, the procedure we do follow is preparing a sampling frame, size of the, deciding the exact size to be taken, and to select the required number of units at random is also important. We have some techniques that will guide you to understand what is the exact sample size to be followed. Now, methods of random sampling, which are the general method we follow? You might have heard about bidding process, lottery. There are large number of bidders in any public programming. Government usually opens the bidders, or tenders are there. So, lottery process, random number tables, using calculator or computers to actually get a particular number to be selected. So, I am not going into the depth of it because it is too simple to understand. So, we may proceed. Suppose there are 50 students, 15 are to be selected randomly to take part in a fest in a class of 50 students, only 15 to be considered who are going to be the part of this fest. Assign roll number from 1 to 15 first to each of the students, then write each number on a piece of paper. So, and then mix up each of those numbers, and you can draw those lottery out of those papers. So, 15 you have to draw, those 15 are actually selected, called simple random sampling. So, this is one of the example of random number table. A random number table by Government of India is also available, from any numbers from a space. If you define the population within, there are population charts are given within here, the numbers can be actually picked off. Okay. Even in the computer, it is always suggested to go by the computer, and computer will give you, if you define your population space from this number to that number, the computer will give you the random number. Even if you do not know some persons in your contact, you simply give them the units and ask them to pick up some numbers. Okay. That is also sometimes defined as random numbers. Now, what about simple systematic random sampling? Systematic random sampling, the randomness is attached, so therefore, it is a probabilistic sampling design. Now, in the systematic random sampling, let me understand very carefully that our population is divided into different clusters. Each clusters have equal chances of selection within, basically within the cluster, each number have equal chances of selection. Now, I will tell you systematically from start with commonly, suppose we give an example, commonly employed techniques when complete or up to the date list of sampling is available. The sample is chosen by selecting an element of the population at the beginning with a random start, and then every kth element is selected until the appropriate size is selected. Let me give you the example here. So, steps of systematic sampling, first step is prepare the list of population from 1 to n. I have already clarified is systematic, we will follow a systematic procedure. So, first you number the population from 1 to n and decide the sample size, how much you require actually, and what is to be, how much is required sample size to be done, we will discuss those sample size procedure in the next class. But now suppose you know the sample size, then you fix up that n, small n, then calculate the interval, interval that means total population if it is 100 or if your interval is 10, then or your required number of sample is 10. So, divide 100 by 10, so interval is 10 divided 10, that is 10. Okay. So, k is the interval, that is equal to capital N is the population size and small n is the small size, sample size. So, randomly selected an integer between 1 to kth item, kth number, kth interval we require. So, let us go to the example. Okay. If we have a population that is of students 30, we require a sample of 10. So, these are there, suppose these are the population given here in this space, it is not exactly 30 here, 12 are given, but if it is 30 we require 10. So, the sample interval, the interval is 30 divided by 10, that is 3, every 3 you are supposed to select 1. Okay. So, basically you will be getting everything, if you are picking of 1 sample, so you will be getting 10 students as your sampled units. So, therefore, this is the k is here is 3. So, select a random sample between 1 to 1 and your ratio from step 2, that is I mean from the sample interval. Now, now here we have selected 2, suppose you have selected first out of the 30. So, now 2, then you add the 3 here, 3 plus 2, then 5 has 5 has been also selected, 5th number student is also selected, then 5 plus 3, then 8 is selected, 8 plus 3, 11 is selected and so on. So, accordingly you can able to get your 10th students for your study. So, this is called systematic sampling procedure, because you have followed a systematic approach. Now, here there are some problem lies in the systematic sampling. If the first group, that is 1 to 3, suppose is the first group, then 4 to 6, 3 and 3 by 3 interval you have divided, then till in another group, this is another group, then another 3 another group. If it is there, if you have selected the middle one, probably the first cluster itself is asymmetric or it is skewed. If this is skewed, you have selected a particular portion from a skewed distribution. Now, in every other cluster there are high chances of selection at the particular position, not other positions. It may be the case that wherever it is skewed, you have selected a person which are not normal. Okay. So, in the systematic random sampling, the errors are expected to be higher sometimes, but it is much better than that of the simple random sampling if and only if your data is heterogeneous. Here we have different colors that represent different heterogeneous groups. Now, let us come to stratified random sampling. Stratified random sampling is applied when your population is actually heterogeneous, and this is preferred, as I already mentioned, when the population is heterogeneous and with respect to characteristics under study. So, therefore, the population is subdivided into different groups, subgroups, and groups are called strata, such that each group should be homogeneous. You divide it into subgroups, like entire population. We know that in our country we can divide the group into like we have urban area by location, urban area and rural areas. We know very clearly in almost all regard urban areas are different than that of rural areas in many socio-economic indicators. So, therefore, rural and urban should not be mixed and random sampling should not be taken. First of all, we need to rationalize by making into different strata. One is rural, another is urban. So, rural has a more or less a similar feature, where urban has a similar feature. So, this is one form of understanding stratified sampling. So, a simple random is then chosen from each stratum and gives equal chance. I mean basically since it is expected to be homogeneous within the strata. So, this gives equal chance to the units of each stratum to be selected as a sample. And so, therefore, now we have minimized our procedure, we can minimize the number of sample to be covered. Had it been an entire population, we followed simple random sampling, and generally the entire population is not homogeneous, not 100% homogeneous. So, therefore, you have to take more sample size, but in this case sample size can be minimum because we have divided in different groups. So, total sample is the addition of the samples from each stratum, as I already said. This is the example. There are heterogeneous in the population, heterogeneous population is given. Now, we divided with different strata that represent almost with homogeneous groups. 3 different groups are defined. From each group we can then take randomly. Therefore, it is called stratify random sampling, because randomness is still there. Okay. Though I mean in the third part, if you are just if you are not referring to the third part, then it is simply called stratified sampling. But if you are including then you are attaching randomness to it, then it is actually called random sampling. If you follow after stratified, if you follow another procedure, not random purely, again further dividing based on certain other features, then still that is not random. We want, if the final frame is of random, then if you are picking up based on randomness, that is called stratified random sampling. Now, similarly cluster sampling is there. We have we will discuss that. Let me finish cluster sampling, and non-probability sampling we will keep it for the next lecture. There are non-probability sampling also, we will discuss in the next lecture. So far as cluster sampling is concerned, the population is also heterogeneous and sampling, but here the sampling frame is not available at the individual level. We simply get the clusters. I will explain what do you mean by cluster. Like NSS follows, they define into some UFS blocks. Okay, blocks are there based on urban areas, rural areas, schools. So, the sampling technique here is population is divided into subgroups, are called clusters. Clusters are formed by grouping units on the basis of their geographical location or boundaries. So, a random sample of clusters are selected, not the persons are selected, but the clusters are selected. The cluster include all type of characters in the population. Clusters are group of sampling units close to each other, crowding together in the same area or neighborhood are actually called clusters. From selected cluster, each and every unit is included in the study. Now, this is the example. If the states are United States, for example, all the states have equal chances of selection so far as policy implementation is concerned. Let us select randomly some cities out of it, then each city has equal chances of selection. So, each cities are actually comparable, okay, because we are assuming that each clusters are actually have cluster of equal probabilities. Then randomly select schools within the cities. Then schools have equal probability of selection, then randomly select students within each school. Okay. So, randomness is followed actually, therefore, it is called cluster and random sampling, and therefore, it is called a probability sampling. So, multi-stage sampling is there. Since we are little ahead of time, I am deliberately closing here. We will carry forward multi-stage sampling. Even multi-stage sampling, basically we are including stratified, cluster and random sampling there, and we will be discussing non-probability sampling. Also we will be discussing probability proportional to size sampling in the next class. With this, let me stop here. We will carry forward non-probability sampling and other details of sampling with sample size in the next lecture. Thank you.